Did you know that water is one of the primary needs in a human's life? On average, the body of an adult human being contains 60% water and is contained inside our cells. In fact, the cells must have clean water in order to survive. Today, 1 of 9 people in the world do not have access to clean water. See this polluted water. In this water, there are so many contaminants that can harm humans. For example, there are arsenic, benzene, mercury, even radium that can point to diseases such as cancer, respiratory, and digestion in human body. As a chemical engineer, we must take action about it. Now let's have a little imagination. What if we can drink every water in the world? Ever wonder how? Let us show you. There are a few types of water purification, including distillation, UV, and reverse osmosis. We can use distillation, but it is inefficient because there are still some contaminants and it takes quite a long time for the process to occur. As a chemical engineer, we make water purification as efficient as possible by considering cost, quality, and reliability. We can do a water purification technique on this bacteria-filled raw water. First, by adding coagulant. It is called by the coagulation process. In this process, there is a chemical reaction to clump water contaminants by adding some coagulant. Coagulants tend to be negatively charged, so the coagulant will attract ions whose charge is positive. Then, these positive ions will attract negative ions also and form double layer. And after that, the next process is called flocculation process. When the double layer is formed, on the outside we will get all negatively charged, so the double layers could not coalesce with each other. And then we add flocculants to unify the layers. These flocculants can consist of cationic and anionic flocculants. Each flocculant will stick to the double layer and will reduce the size of the double layer itself. Then we could stir it up to unify the double layers, and the clump double layers will settle in the bottom of the container. After that, the last process is filtration. But before we filter the water, we have to add some disinfectant to kill all the bacteria and other microbes. After that, we can use any kind of sieve, but the recommended one is cloth filter, so all of the clump contaminants will not be mixed, again with the clean water. And that's it! The water is clean enough for us to drink. Do you think? It's actually never been impossible to drink any kind of water in the world, as long as you know how to treat it, that is.